Hi everybody. Thank you for joining me today in such overwhelming numbers. Welcome to our talk on error handling, a mystery in red. Before we get started, a quick shout out to our sponsors. Thank you very much. Without our sponsors, none of this would have been possible. Well, I'm Fred. I'm doing PowerShell for most of my professional life. It's what turned me from a victim into an actor. It's what gave me the power to finally replace the beauty of the user interface with the nightmare of these red error messages on screen. It's been taking me along since then. I'm using it for my private life, including building books and other fun, including managing my cocktail recipes. Mixing is still a manual thing. And well, if you want to reach me after the conference, you can find me at best under the PowerShell Discord. Name's Fred. And I've got a channel just for my toys and bragging about them. So come on over. A few more of my code examples. We're not going to be using them today, but if you want to look more like what the hell is that guy coding, these are the key projects and locations to find more. So, my first contact with PowerShell was trying to get that one line to work, and I was kind of drowned in a sea of red. Error handling. Errors are a common day. We see lots of them in PowerShell. Nice, comfortable color. And once we start working with this, sometimes it works exactly as expected. Sometimes it appears to work exactly until I need it to work. Then not so much. I'm sure most of you have already had the pleasure of a scheduled task reporting, I completed successfully. And when you turned on the transcript, it was like 10,000 lines of error messages. And line indexes and other hard to read stuff we don't read usually. So I decided, hey, why not take a look at what's happening here? Take it off where we usually stop, digging deeper simply because we can't justify it in a workday. And well, it all starts at the good old tradition of terminating versus non-terminating exceptions. We've realized, okay, with some errors, PowerShell is just going to pretend nothing happened. Here's some red, have fun, I'm going to continue in the meantime. But for others, our scripts, for some arbitrary reasons, appear to fail. Classic example, I'm trying to remove a user from an Active Directory group. The user was never a member of that group. And still, my script insists, I need to die now. Why? Classic example that always works well in showing the issue is this one. I'm trying to remove a file, and if it failed, I want to react to it. Try catch, classic programming paradigm. And, well, we didn't get the warning. It did not trigger the catch. I mean, the warning would have been kind of pointless, but still, PowerShell ignored that this command broke. It just continued. And we learn that if we do an error action stop here, well, suddenly our try catch is working. We learn, okay, if I want to handle errors reliably, I just always paint on error action stop, put it in a try catch, and I'm good. So our scripting can continue, we're unblocked, but what happened here? Why do we even have two different kinds of exceptions? The thought behind them is one exception says, hey, all future success is impossible. Abandon all hope. We don't need to continue here. The other part says, okay, this one data set might have been a bad apple, but maybe the next one will do. So the key reason behind this thing, and the key reason behind this thing really is the PowerShell pipeline. It is one of the key features we need for the pipeline to even make sense, to make the pipeline resilient. Quick example, I have a folder with a few log files. Imagine this were not 10 log files, this were 10,000 log files. And you now have a log rotate script that is trying to do get child item, pipe to remove item. If all exceptions only would be murdering our code, this would work well until somebody opens one of those files and keeps them open. So this file is now being logged by Excel, and I'm trying to remove all files in that folder with this nice pipeline. The remove item error action stop simulates this. I decided I want this to die. And oh, it failed. The entire pipeline stopped at that location. And if we now take a look, all the files after free are also still here. If all errors were lethal, we could never use the pipeline for this code because we couldn't rely on removing them. We also are now in an inconsistent state. It's not just that we could not delete the file that was in use. We also don't know how many did we delete, how many did we not delete. We don't know. So that is the key reason why we have terminating versus non-terminating. This reason is not just for ill. It also has some extremely good capabilities to kill a pipeline when it actually needs to die. For example, imagine we do something like this. Get mailbox, pipe to get mailbox statistics. In a tenant with 100,000 mailboxes, this is going to take a few hours. Now I'm going to write DBA data table into a SQL instance, database table mailboxes. Imagine our SQL server has been shut down. Doesn't matter how many mailboxes I'm trying to send there, this is never going to work. At this point, our pipeline can be killed before we actually retrieve the first mailbox. So it dies after the first seconds. If we were just going to ignore this with non-terminating exceptions, we would now be sending, over the course of several hours, all of those mailboxes in there, and they would not end in a table because the SQL server is off. Can't afford to do that. On the other hand, if one of the mailbox objects that you're generating is missing a property or doesn't have the correct data type for the table, maybe the next mailbox object is going to be properly formatted. So, the next part about all this error handling, especially in the context of terminating versus non-terminating, that we need to look at is why does our orchestration tool or task scheduler or SCCM agent or Intune or whatever say it all worked, tasks successfully completed? What is the requirement for it to not be successful? Fundamentally, they just launch PowerShell.exe or pwsh.psx. They start a process and they check for the exit code. And, well, the thing about PowerShell scripts that we start with PowerShell.exe is a parameter. When PowerShell closes afterwards, the only situation when PowerShell is going to go to exit code 1 is either we did exit with an exit code and got lucky that the PowerShell host that's calling it respects that, which is not automatic. Any DBA amongst us will probably have not learned about that. Or if the last statement in our script was a terminating exception. Non-terminating exceptions don't count. As you can see, this example script is going to produce quite a bit of red. I'm going to demonstrate my poor mathematics skills. And, well, let's give this a try. So, PowerShell is kind of busy scrolling the screen. Since this is VS Code, scrolling the screen is not expensive, fortunately. And what did the last exit code say? Exit code 0. Our scheduled task has now completed successfully. Everything is well. I hope you do have logging. That said, if we do something a bit more lethal, error action stop, the entire script is going to fail in line number 2 with a terminating exception. There's not going to be a right house done. There's not going to be some numbers, and the whole thing is going to be correctly recognized as failed. Our task scheduler would now report this exit code, and we could rely on this went wrong. So we now have the difference between those two for now. We're going to shake that knowledge in a little bit. But before that, we now are in the situation that maybe the code that we run didn't produce an error. We need to generate a new error. We need to implement this in our own code rather than just reacting on what some PowerShell command did. So how can we do a proper non-terminating exception? It's actually really simple. Under a specific condition, let's say if 2 equals number entry, there's this nice command called write error. And there we go. Fire, and what could possibly go wrong? We get an error, our code continued. Let's try this again, only this time with error action stop. The code stopped. There's just one problem. With the previous notation, we actually processed the second value. That was a bad value that was supposed to have an error state. We probably do not want to continue processing the problematic number. However, if you're not terminating, PowerShell is going to execute line 57 and then happily continue on. There are ways to do this, of course. We're telling PowerShell to continue. Since we are in a for each loop, continue is going to jump to the next number. If you're piping it, well, we only have one number, so process ends. If you're explicitly offering multiple numbers, it's going to move on to the next number. And with that, last fix, fire, and there we go. Non-terminating exception implemented as it was meant to be. Remember, this is intended for a future potential object might still lead to success. If we have a reason to assume our pipeline can never succeed, we need to instead produce a terminating exception. So I'm just going to steal this. And instead of a write error, we can now do something fun. We can do a throw statement. Try that again. And don't watch the spoiler below. Our command died as intended. I can now try catch this. And by the way, we have this nice $_ in a catch statement, which is the current error. Now there's just one problem with this, and that is, unfortunately, the throw statement does not throw a terminating error. Yep, it does not. Just continue on. Happily ever after. So, let's fix this. This is going to fail, as we saw. We could now accept that this is the way it is, and I'm just going to do the same thing as with write error. But at that point, why am I not using just write error? No point there. So if we want to do a terminating error that is actually terminating, there is a nice automatic system variable in PowerShell called $PSCMDelete. $PSCMDelete is a reference to our current command. In order for you to actually have this, make sure you either have at least a parameter attribute or a commandlet binding attribute on your command or your script. Kind of important. And your command reference has a few methods. One of them is throw terminating error. It only wants one single object there. It wants an error record. Great. It wants an error record. Only one problem. We don't have an error record. Whatever shall we do? We will need to investigate a little bit. There is a data type called error record. And we now need a new one. I don't know exactly what information it wants. I can't memorize that. But if I call the constructor new without any parameter, it will also print that on screen here, what the legal options are to create it. One of them requires us to already have an error record, so that one is out. But the other one is fine. So in this case, I want an argument exception as the first thing, an exception object. Second value is just some string, can be anything. It's kind of an ID. Ideally, the error ID should never be localized. I would also prefer exceptions not being localized, but if you have to go multilingual, the error ID should not be localized, so you've got something to rely on. Next one is an error category. Can never memorize that one. Invalid argument, and as the final value, the value that we're complaining about, which would be more accurate like this. Doesn't look good, but it's how it works. And with that, we now have an actually terminating exception in our code. And actually terminating means that now our pipeline dies, as it was supposed to. And here's a second characteristic of actually terminating errors. They fully ignore error action. Error action has never been for terminating errors. They always are completely ignored. They are only for non-terminating. Which is it's also fine always to provide error action stop, because the terminating errors are already stopping anyway and ignoring it, and the non-terminating do stop. So, and with that, we're good. Yes?
We found that it is method that if you set error action preference to continue globally, then this will not terminate.
This should, in all cases, terminate, no exceptions. Should. But we can do that, test that. Error action preference, continue. So that should be default, because actually error action preference continue is the global standard, global default value. So we've got that. Cover that, cover that. Now we know the terminating exception, we know the non-terminating exception. Let us introduce the sometimes-terminating exception. So I've got this nice little 3 lines of code. I'm going to need to paste this into the editor because I'm not using the integrated VS Code console. As you can see, while we did get divided by 0 exception, the ending statement still executed. This obviously did not terminate. Well, let's do the same thing again, only this time we do it inside of a try statement. Now it did catch. Sometimes terminating exceptions. Specifically, methods and operator errors. are only terminating when they happen inside of a try-catch. Specifically, this does not say try-catch in the current function or try-catch in the current module. The try-catch can be anywhere in your current script call stack. So if you have a script that's calling a module that calls an internal helper module where there is an unhandled method error, your error action is not going to work all that well. But if you put a try-catch around the method, around the command at your script level, you can still catch it, handle it, suppress it. So if you're sometimes wondering like, how do I get this error to go away? Try-catch might be the answer. So why? What's the point? Simply put, with methods and operators, we have no way to pass them an error action. They're not PowerShell commands, they don't take parameters. We might be able to do an error action preference, which will work. Error action stop is also going to kill this. But that we can't propagate this into internal helper modules. So we decide, okay, we're going by probable intent. If a developer is putting something into a try-catch, the developer is expecting it can fail, and it should be caught. So that's why try-catch is going to catch those, while it will continue if you don't do that. So basically, the throw statement is an operator error or a statement error that defaults to error action stop if you don't say anything otherwise. So, time to do something with that information that we now have. We have our exceptions, and we have some issues that we can solve with that. First of all, I've got another test folder with a few log files, and I'm going to let the pipeline run after logging a few files, so that this should then lead to issues. Now, Excel, you're okay. Invoke item opens a file in the default application for that. Quite useful. So, we are going to try to remove all the files, but this time I don't want to see the errors, and here's a parameter I rarely see used, error variable. Error variable allows us to, rather than printing red on screen, we are writing all of the errors that happened, that were not terminating, because terminating would have been a game over anyway, into the variable named failed. Please note there is no dollar in front of it. If you put in a dollar, the PowerShell parameter binder is going to interpret the variable, look for the name inside of that variable, and try to use that. But just not going to end well. So, some things failed, of course. If we take a look at the files, only the 3 files that are opened. And in our variable, there are now the 3 error records that it did not print on screen. And here's the next fun part about all of these error records. They have a property called target object. So with that, we can actually figure out against what object it did not work, and can then process that programmatically, which solves a lot of our problems where we split out the pipeline because we want to verify for each individual object just what object failed. With error variable, we no longer need to break up the pipeline, which is quite useful. We also no longer need to break up the command, which leads us to another fun one after a little intermission, because write error, our own non-terminating exceptions. What about those, and what is their target? Let's try this. Last error. Target object. Nothing there. There's a parameter for that. So you can make sure that your non-terminating errors also have a target to work with. So you can implement this yourself, makes your error handling a lot easier later on. So, a horrible, horrible design pattern I see all the time is this. Remoting and error handling. I want to remote into a few computers, and I do this in a for each loop, which is not going to work because none of these servers exist for some reason. And we can see this is taking a little bit of time for it to go through all of the remoting issues. So again, I'm not going to do that. Let's do the same thing again in Smart. When you give invoke command the entire list of targets at once, it's going to execute that in parallel. Of course, that means we can't do an individual try catch, but with error variable, we can still know against which target it failed. So, leading us to that one big issue about error handling. I'm seeing way too few traps. The trap statement, quick show of hands. Who of you has used the trap statement before? Excellent. More than I feared. The trap statement is, simply put, a global try-catch over everything that happened after. So let's take a look. There's a trap statement, and this is going to trigger whenever we have a terminating exception afterwards. This line is not going to execute if nothing goes wrong. It's fine. Execute, and we're good. So let's assume this fails. We divide by 0. Execute it. And the trap did not trigger because it was an operator error. There was nothing bad happening here. Or did it? No, actually it triggered. But since the trap statement didn't have anything telling us to kill the script, it just continued. So we did catch the error, but bearing other commands, the script continued, and we now have exit code 0, everything worked out. So, failing that, I'm going to do a throw statement. And it worked. It caught it. We did not tell it to stop, so it didn't. If you're telling it to ignore the error, it's just going to continue. It's just going to continue. No, it's still being caught. The throw statement and the trap statement have a weird relationship in that the loop was interrupted. We did not continue, but the throw statement, after the trap was resolved, we continued after the for each loop into the done. So there's still something odd going on here, or something unwieldy. We should be reacting in the trap statement to something failing. So let's do that. I'm going to throw the original error as a terminating exception. Otherwise, it's the exact same code. And now our trap is going to trigger, our trap is going to kill everything, and the script is exit code 1, everything failed. If we handle our code inside of the statement, even though we have a trap, I can still do try catch inside. I can still do error action ignore. It's all fine. I can do non-terminating exceptions. That's fine as well. They are going to execute and be done with it. One of the common design errors I'm seeing with the trap statement is that people say, okay, hey, I'm going to do a trap. Now I don't need to do any other error handling. The real benefit of the trap statement is that I have a central clearinghouse whenever something fails, and have a central location to do things like finish logging, make sure any error I handled or didn't handle still leaves a trace, clean up resources I need. You still should be doing try catch on individual steps that could be failing. Which leads us to one fun aspect here. Break and continue do not exist just for loops. You can also use them in a trap statement. And in that case, you get a bit of a headache. This is pretty much the same thing as throwing a terminating exception. It's only, I'm slightly allergic against that one because I'm burned by break outside of loops, so I'm trying to avoid that. But otherwise, it's doing its job. We can also tell it to instead continue. If we tell it to continue, we consider the error handled, and the script is going to continue at the next step. So I'm going to do invoke fail, and I'm going to execute here, but the invoke fail has a write host done. This is important right now, because if I now do the continue, our function invoke fail completely failed. The continue statement here did not continue after the exception happened. It continues at the root level after this command has been resolved, which did not execute to the end because of the terminating error. So generally, this is something we can do, but it provides little value. So I would advise against it. Now, there is a consequence from a script design perspective, which I do with every script. This is a key takeaway to remove most of the headache that I've inflicted on you so far. Or at least mitigate, like kind of my bribe to you. This is my default start or default layout for a script. You have the parameters at the beginning. We do an error action preference stop and a trap statement with cleaning up the logging, cleanup, and everything after. This means that any error that happens in my script afterwards, in whatever way, either I explicitly handled myself, I can still do error action silently continue, I can still do error action ignore, I can still do error action stop, and within a try catch, I can ignore it and just inherit it. That's fine. All of those are still being caught, and anything unexpected is ensured that it's at least still in the logs. And I can guarantee that all the cleanup happens. In all other cases in the script, I can just conveniently do a throw statement, because now we have a guaranteed error action stop. The throw statement is reliable. And I don't have to care in each of the other places to do the cleanup. I can do it once in the trap statement in case of error, and it's safe. So that's my default template out of the whole thing. Yeah, that's the story so far. One last quick thing, if you are working with error action preference, the default value for that is continue, and it's being inherited. And what happens when you do error action stop on your function? When you do error action stop, what really happens is it sets inside of the function that you're calling the error action preference to what you provided. And your statements inside of your function look at that error action variable. So the fact that it's a parameter or there's no error action variable that you need to place inside of the parent block, it's all handled by the engine here. And if you need to react to under what mode am I, check for the error action preference variable. Especially if you have some reason to locally override it and then need to go back to what was before. You don't have to react to what the user bound. If, however, you have some reason to react to did the user provide the error action parameter, this is not a check, because you can't tell the difference between inherited error action preference and parameter bound error action. In that case, the inheritance works as well. In that case, what you need to do is to check the PS-bound parameter system variable to check whether it was provided or not, irrespective of the current value. Yeah, that's it. You survived some of the headaches, some of the mysteries, and I hope a few solutions to the problems you can apply into reality. Any questions? Or need some time to digest this? Yes?
Isn't it best practice for a function to adhere to error action given to the function itself?
Is there best practice about dealing with the error action in the context of the function itself, not like a script design, but in a single function? I try to do a local small try catch. I usually don't use the trap statement inside of a function. I do it in a script. Inside of a function, I explicitly try to handle every call that can go wrong. Individually, I try to avoid broadcasting it, amongst other things, because I can be sure that even if I misestimated that. Since in the script that's calling that function at the end of the day, I still have the trap statement that's going to catch anything that I didn't think of at the time. But mostly everything that leaves the process is a risky thing that probably should be handled. So that's really okay. Sorry, let me repeat that. When I want to throw an arrow inside of the function, do I use right arrow? Do I use throw? What exactly do I use? This really comes down to the different design consideration, terminating versus non-terminating. When the command cannot possibly succeed, there's just no way. I'm trying to write to a database and the SQL server is down. I'm trying to get into the internet and I don't have the proxy configuration needed for that. Whatever. At that point, I do a terminating exception. Sometimes I'm lazy and using throw. Most of the times I'm in that case doing a terminating exception, like with $pscmdelete.throw terminating error. You can pass that $pscmdelete variable to a helper command that implements this weird object building and throwing activity for you on your behalf, so you don't have to make your code harder to read. I'll add in a link to the GitHub where I have one of those functions for reference as a thing you can just plug into your code for that. But yeah, it's the primary consideration. Should the command permanently fail or has another object a chance to succeed? And if I have another chance to succeed, right arrow. Yes?
So the C# world, it's generally bad practice to just throw the exception.
Okay, question. In the C# world, we often enough have typed exceptions, different specific exception types that we're just throwing, and we can in the catch block also filter for different exception types to have separate catch blocks for different kinds of exception types. What's my take on that in the PowerShell world? In PowerShell, we have the same ability, but in practiced reality, the actual number of different exception types we can differentiate based on the type of the exception thrown is, let's be honest, already an edge case. It's so rare that it's not something I take into consideration. I just do one catch block and decide on the error record how I'm going to continue. It might be different if I have if I'm building a module that is heavily integrated into a C# world library. Just for example, Exchange Web Services, EWS, that's basically a bare-bones script wrapper over a huge DLL library, which very much do typed exceptions. So in that case, it might be worth it. But it's extremely domain-specific if at that. Yes?
Does it give the good stack trace that can help arrow down when the error?
Okay, question. In that template that I offered, is the error as the stack trace a useful tool? Is it still correct? And the answer to that is yes. Since we rethrew the original error, $_, no quotes around it, no message included in that. It is the original error with the original stack trace where exactly it happened. Let me do a quick demo of that. Not a good demo, but good enough for the points of the discussion. If I'm doing that, it failed. And if I now look at the last error and the script stack trace, it's in line 16, exactly what happened. The trap statement itself is actually invisible as far as this is concerned. For those who've never dealt with that, the script stack trace, we read it from the bottom to the top. It usually starts in line number 1, script block, no file. That is our interactive console that triggered it. And then moving up, that's the next position in where things went wrong. Line 16, we didn't have any internal functions, any internal helpers, so that's it. If we do the same thing in, I think this one, and then do the stack trace, Where did I fail? So that one. Script, stack, trace. Now we get also the function invoke fail where inside of that script it failed. This is, well, a good way to troubleshoot your scripts if you break your scripts down into individual functions, because then you can, on the script stack trace itself, figure out where exactly in your process you failed, what was the context, not just the line number if you just do a script that runs from top to bottom. If you want to know more about my entire design approach to script design, which also takes this into account, I did a session on that in break, PSConfEU 2023, so the recording is on YouTube. Yes? Is there any situation where I use the exit command over any of the other tools available? No. The exit command is a command at the PowerShell host to exit. And the actual events happening depend on the implementation inside of the host. So the exit statement is inconsistent based on from where do I execute it. For example, if I do exit in the ISE, the ISE is going to be closing, but first it's going to prompt you, do you want to save your unsaved files before I'm killing them? If you're doing it in PowerShell.exe, it's going to close. If you're doing it in the VS Code integrated console, well, you probably didn't want to kill me, didn't you? I'm just going to stop doing it current script. If you're doing it in the PowerShell agent for the SQL Server agent, well, it is going to end the script, but it is going to fully ignore any exit code you provide. So this is simply a statement that the exit statement just isn't reliable, and I have no use case for it. If I want to kill the command prematurely, I hit Control-C. If I want to kill it in error, I'm doing a throw statement, and the error handling resolves its natural way and should also lead to an end. And if it's in a scheduled task, the entire scheduled task stop PowerShell.exe closes, and we get exit code 1 task failed. So, no, they're simply reliable tools in comparison to that. Yes?
What would be then your best practice to return an exit code, for example, in a scheduled task?
So what would be my recommended way to produce an exit code in a scheduled task? For one, I try to avoid doing that if I possibly can. I prefer not working with exit codes. If I possibly can, however, is a constraint, because sometimes we do have to produce an exit code. And if we absolutely, without fail, have to do an exit code, there's a way to do that that is not reliable, that does not rely on a statement to the PowerShell host, and that is system.environment exit. It takes a number, and that exit code is a direct command at the .NET host, at the .NET application, and not a request to the host to do something. And that is reliable, as far as I've seen. I've never had any case where that was not the way that would work. Anybody else? Well, if not, thank you for joining. Hope you have a great rest of the conference, and you know where to find me.